So today I'll be talking about a project I did, which was visualizing Olympic medals, and it's sort of a part of a bigger plan, and it's part of a bigger plan that I'm working on at the Alan Turing Institute, which is a recently set up UK research institute for data science, and I think one of the really, no threads, very good. One of the really important things about data science, it's not just the sort of fancy mathematical models, but also building things that people can actually understand and hopefully sort of increasing the data literacy in the world. As you might guess from my past history of talks at NDC, it's all going to be using F#, but the project is actually running as a web page with most of the interesting work happening in the browser. So I'll be talking about F# and Fable, which is what I've used to implement it, and Fable is a F# to JavaScript compiler. And aside from the Alan Turing Institute, I'm still also affiliated with F# Works, where we do F# trainings and such. And the other important part, aside from the Alan Turing Institute, is Google has this digital news initiative, which is sort of funding interesting digital and news projects. So they gave me money for doing this, which was very nice. Yes, so you can't quite see this, which is good. You can see the shades. You can see more of it in the news. And when I started the project, I sort of didn't really, it was like half a year ago, before post-fact was everywhere. And so it sort of fits very well with what's happening in the world. And I think there's sort of, you can read a lot about how people are sort of less interested in facts these days, and I think that's partly, there's a lot that could be done there to make people a bit more interested in facts. And when people sort of complain like, what's so bad about the world, they will often say that it's like, let's blame Facebook because Facebook created these social bubbles. And I think that's partly what happened, but what really happened is that Facebook just made it really easy for people to sort of share their opinions. So if you have a lot more sort of options these days to actually say what you think and get people to listen to you, and it works really nicely for having opinions, but it doesn't really work that well for sort of facts based on data, because you can't really go to Facebook and say, given this data coming from the government data set, I'm making this factual claim, and you can derive other factual claims from it. So I think what really would be sort of where the project is coming from is this idea that maybe we should make it a bit easier for people to work with facts and work with data and see what they can find in the data, to just not have opinions, but also be able to back it with some data. And there's been sort of a recent trend where more and more news and more sort of stories are data-driven. So this is really a nice example of what New York Times did around the Olympic Games, where they did like a visualization where you can sort of see over the entire history of the Olympics who was winning what number of medals. And it really makes you think about what's happening in the world, because you can see the two massive gaps there. That's the two world wars where no Olympic Games happened. And then there's this weird spike with Soviet Union and US, which is the Cold War, where first, US didn't go to the Olympic Games in Moscow, and then the Eastern Bloc didn't go to the games in the US. So you can sort of, it's a really fun way to explore some information And I think this is a really nice piece of work, but it has quite a lot of problems. And first of all, you have to trust the New York Times that they did the analysis right. They, I don't know if, I think they didn't give you source code for everything they did, so you can't really sort of run it and get the same thing. You sort of can, but you have to be really good developer. You can't really see if the visualization is sort of doing some obvious mistake. Like you can count football as 1 Olympic medal or as 20 Olympic medals, and that will skew the data quite a lot. So you can't really sort of immediately see it when you go to the website, and you can't also say, well, this was a nice chart, but what if I only care about athletics? So you can't explore it further. And this is what I'm sort of trying to do differently. And I'll just give you a short demo, and you can then have a look at this and play with it on your own. So I think this is what I wanted to show. I'll give you links as well. But the project is all online, and it's there's a couple of different visualizations about Olympic Games. So let's start the day on a simple, easy note. This is the table of the medals awarded over the entire history, and it's calculated from a raw data set, which is just a CSV file with every single medal ever awarded. And what's interesting about it, or what's different about it, is that you can have a look at the source code, and there's some bit below which is sort of a hacky visualization to make the medals look pretty. But this is the core of what's happening. So take the Olympic data, group it by athlete, sum the number of medals, sort it by gold, take the first 10. And this is the interesting bit, and I'll get back more to it. Right, there's a few more fancy visualizations. So this one is showing over a timeline how the medals have been changing. So if you wait until it loops around, you'll see that early on it was pretty much just Europe, and then it keeps getting bigger, and there's more and more medals from other places. And this one is fun. So this is someone in a newspaper actually did this, where they took Michael Phelps and compared him with all the countries, and now he's winning over all these different countries, and that's because I did the visualization before the Olympic Games, and he won lots more. So now he's like way on the left. But you can change it and say, let's skip only 40 countries, and let's get more, and then I can refresh it, and I will immediately see the different results. So you can see, like, if Michael Phelps goes to Olympics again, he'll have to beat Mexico, but he's already beating, like, Czech Republic, for example. So the interesting thing here is sort of the idea that you should really be able to modify it. And it's like in the good old JavaScript days when I was learning JavaScript, when you would just steal someone else's rollover effect and put it on your website and create sort of derived interesting things. And I could talk a lot about like what's interesting about this and why everyone should be using it, but I think there's a lot of things that are sort of interesting from the developer point of view, so what's behind this. And I'll talk about some of that. And there's two things. One is I was sort of trying to figure out what's really the common theme that appears in many different parts of this project. Like, it's a fairly sort of, it's a project that does quite a lot of different things, but there's one repeated theme where I think what you get from using F# for this kind of thing is that you can really focus on the domain. Like, you can really focus on what is it that I'm working with. What are the kind of data transformations? What are the kind of visual elements, and so on. So I think the really important technical bit here is to focus on the domain. And when people sort of talk about object-oriented programming, functional programming, any other programming, they'll often get distracted and focus more on the mechanisms. So with functional programming, I'm going to attack my own lines because people will start talking about functors and monads, and that's all just sort of the technical stuff. And I think what I found really nice here in the project is that you could really start by focusing on what is it that I'm doing. So this is one thing I'll get back to a couple of times. The other thing is Fable. So Fable is the F# to JavaScript compiler for the 21st century. And that means a couple of things. It means that it generates reasonably nice JavaScript. For sort of things that translate well to JavaScript, it's nice JavaScript. For things that don't translate as well to JavaScript, it's reasonably nice. But what Fable is also doing is that it's well integrated with all the modern JavaScript ecosystems. So it generates, it's using this thing called Babel behind the scenes, which will then sort of generate nice idiomatic JavaScript in the thing that runs in the browsers, or ES6, or ES whatever. And that means you get sort of easy access to all the other fancy JavaScript tools. I'm not really a JavaScript developer, but I managed to use Rollup to package my script and make it easily sort of small JavaScript. You can put in a web page. You can run it through all the node stuff and so on. It generates source maps as well, so you can sort of debug it in a browser. The Fable project has a really nice and welcoming community. There's a Gitter page where you can get lots of help. And in a way, I think it's for many people, it's possibly the easiest way of starting with F#, because if you have done some Node, then this will just work. And if you want to learn more about Fable, go to Fable.io. There's plenty of documentation and lots of fun samples. So now I'll get back to what I was talking about, the domain, and I'll go through 3 different parts of the project. And the first one is the data transformations. And I'll go back to the demo and show one more thing that you can do here. So the fun thing is I can look at the source code of any of these and just delete it, start from scratch. And this is using the Monaco editor, which is what VS Code is running. I built a little language that's running here and lets you compose these transformations. And it's using the sort of nice ideas behind type providers. So when you do group data, it will tell you, well, here are your available grouping keys. So let's do, what did I want to do? I think a fun visualization is to find the number of teams per games and how that's been changing over the past years. So are there more teams coming to, or more countries coming to games these days? So we can group this by the games, and then here you'll get like all the available transformations, so I can count the number of distinct teams, and I'll just say average year, because per games this is always going to be the same. So we'll get the year of the games, and then I can say then and do some other transformation. So I'm going to sort this by year. And then I'll get a series, which is key value mapping, with key being the year and value being the number of teams. And this is my data. And then I'll be able to say chart, I think, area, and run it. And here's my chart. And you could fiddle with it a bit more, like add a title. But yeah, you can see some interesting things here. I think the sort of V shape in the 80s is the Cold War. So, but when you sort of see what I was doing, you can roughly get some idea about what's happening there. But oh yeah, there's one more important thing, which is it's all been using dot-driven programming. So this is one sort of joking term that people use when talking about F# and type providers, which is that you just type dot and pick one of the things. But I think this is actually a really nice way of doing things. And it goes all the way to actual values in the data set. So you can even filter by athlete, and then it will give you the athlete names. Which I think is just a sort of curious idea, because you can do quite a lot just by typing dot. So dot-driven programming is nothing to be ashamed of. But I was showing you nice dot-driven programming, and you could see how it works. But really, when you want to write this, when you have this idea of what it should look like, you have to go back or step back a little bit and say, what is really the transformation? Like, as I'm doing the dots, what is it that I'm actually composing? What is it that I'm building? And so you have to sort of slow down for a bit and really think, like, what is this? And this is where I find F# extremely nice, because when you say, what is really this transformation? Well, it ends up being just a discriminated union in F#. So transformation, that's the second bit, says a transformation is either I'm dropping some columns, which is one of the operations you can do, or you can sort the data by something, or you can group it, or you can do paging. And if you look at this, you'll sort of figure out after a little bit of staring what's going on. So grouping, that's the sort of most interesting one, takes a string list, which is the list of the column names to be used as the key. So I was grouping it by games, and so the string list would be just games. And then it's a list of aggregations. So this is what I want to calculate over the group. So I do a grouping by game, and then over every single group, I apply some aggregations, like count all rows in the group, sum a specific column or average, and as you're using this, you're really just composing a list of transformations that define sort of sequence of steps that you want to run. So I talked with a colleague who was doing something very similar, and they basically ended up having exactly the same structure, but for composing some dynamic queries to an SQL server. And really, once you sort of start thinking, what's the domain? This is a really nice way of expressing what's behind this. Now, I could write the whole code without having this definition, but it would be a complete mess. So this is what is a transformation. And once you define the transformation, you can do all sorts of operations with it, because now we know what we are working with. And I have a little demo. So I'll just show you a little bit of this, which will illustrate some of the things that are happening behind the scenes. And I'll run it in F# Interactive. So here is slightly extended version of what I was showing. A value can be string or number. This is my actual runtime data. And then here, I just added all the other aggregations that I can do. And I also added sort direction, so I can sort by sort of ascending or descending order. And when I do paging, I can take a number of rows or skip a number of rows. And then the transformation type is what you saw before. And there's one bit that I'm going to skip. And the bit that I skipped, what it's doing is that it's parsing URL query. So the green bit in the middle, when I write my query in the browser by doing dot, it will then build up this discriminated union, serialize it into string that looks like this, and send the string to the server, and the server has the data and will evaluate this query. So here I'm filtering to have only games, only data for Rio, and I group it by athlete and some gold, and I'm going to get the top 3 athletes based on the number of gold medals. So what I skipped was the bit that parses this fancy string. And then I can load some data. So here, this is roughly what my data looks like. It's just a collection of rows, but I pre-processed it a little bit. And then the key bit that I need to write is actually a really simple function, which will say, given the data and one of the transformations, apply the transformation to the data. And so what I'm doing here is I take the transformation and I look at the different kinds of transformations that I need to implement. So I do also have an empty transformation. And if the transformation is empty, I just return the objects without doing anything. So this was easy. But I do have some more interesting transformations. So I have paging, which takes a list of take or skip, and there could be several of them. So I'll take this list of skips or takes, and what I have to do next, so this is where it gets functional, because what I need to do now is to use fold, and what that means is that I'll sort of iterate over all these individual operations, skip or take, and for every single of them, I'll get my data, my objects, and I'll have this paging operation, and just so that it compiles, I'll finish the structure. So what I'm doing here is I take the data, the objects, and iterate over all the actions I want to apply to this, and then I have to look what kind of action is this. So if this is paging dot skip, I want to skip some number of rows, then what this object means, it's a sequence of array that represents row, that represents individual row with sort of key and value pairs. So really, what I need to do here is to say, skip this number of elements in my data, and for the other one, I need to truncate, or I could say take, but truncate, and now the F# compiler is telling me I'm doing it wrong, because I didn't change this to the other option. So if I want to take an element, I'll have to truncate. And so I think what's nice here is that you really, once you have the domain model that represents what is your transformation, you only have to follow what the domain model tells you. Like, if it's paging, I have to given my data, I have to evaluate the paging, and all the other ones, I'm not going to write all of them, but they'll look very similar. So for sorting, what you have to do is that you take your fields that are supposed to be used for sorting, and then we sort the data, and we compare to rows depending on the fields that we specified. Then the second one, if we want to filter, we are given a list of conditions, and we iterate over all the conditions and filter the data that we've got based on the condition, and just check that the actual value matches the one that we wanted. And finally, the grouping. Finally, the grouping is, again, pretty similar. We'll construct, we'll get the objects, use the f-sort function to group it, and then for every group, we apply all the aggregations. So I don't necessarily I'm not showing this to explain to you how every single line of this function works, but the reason why I'm showing this is that you can see, like, this is entire function to evaluate the aggregations. And if I then parse my request and actually evaluate it, then I get Michael Phelps, Kati Ledecki, and Simon Biles. Or my pronunciation is probably wrong, but there you go. And the reason why this works so nicely, I think, is that you really had the domain model there that explains what is it, and you can then sort of nicely decompose the problem, where one problem is take this nasty URL, turn it into the nice structure. Another problem is take this nice structure and the data and transform it, and so on. So it's sort of all built around the structure. And the other fun thing is, once you have this definition, I showed you a piece of code that will actually evaluate this on in-memory data, but equally you could write a piece of code that will take the query and generate SQL and run it. So you're decoupling the actual operation from the sort of idea what it actually is. So this was one of the examples. The other one is, so this is where we will have computer science. Because the other bit is modeling the program structure. And what I mean by this is the piece of code that I was writing in the browser, it looks like some sort of program, as it is some sort of program, but when we parse it, we'll build some representation of this again. And that's what people call abstract syntax tree, because everything has to be abstract. And the reason why I think this is interesting is that this idea that we could treat an article in the newspapers as a program as really lets you do a lot of fun things. So when you look at newspaper and you read the article, like, that's the only thing you can do it. Or you can sort of tear it apart if it's printed and use it for drying stuff. But if you have a program, there's lots of things you can do with programs. Like, you can install ReSharper and let it fiddle with your program. So we know how to do lots of cool things with programs. And what you could do with programs that work with data in the news, well, you could actually go back to the original data source and check how credible that data source is. And if it says brightbar.com, then you'll just display a red flag Or you could provide some usual programming tools, so you could sort of let people fiddle with the program and help them and say, do you mean this? Or what if you also, like, wouldn't you also want to see this for this other data point? And you can sort of let the users play with it and find some other information, which is what I was showing in the previous demo. And so there is one other thing that I was working on that I did as part of this was you can look at the visualization. So this is plotting just medals for table tennis. And you can see the source code. And if you're a programmer, you'll figure out how this works, and you'll be able to change things. But really, most people reading the news aren't programmers. And so what you can do instead is, and this is where the program structure is really important, because you can do analysis of the program structure and figure out where are some places in the program where we could have done things differently. And so what this did is that it looked at the code and said, well, you're saying, let's say in the grouping, you're saying count all .sum gold .sum silver, and there's other members that were available there. So here's a drop-down, and you can add some of them. Or if you're not interested in table tennis, but instead you're interested in cycling, then you can go here and say, is there some more? I think this is it. Give me the visualization just for cycling, and I picked cycling because I know it's going to go very well for the UK pretty soon. We'll just have to wait. But the idea here is, this is all coming from the code. Oh, yes. And not only it's generated from the code, but it also changes the code. So as I was clicking on things, here it changed the piece of code that was selecting what I'm doing. This is really just like what ReSharper does when you're writing code, except I'm now doing it on a visualization that's telling me something about the Olympic Games. And this is another fun part for the implementation, because what I had to do was to take the source code and build some structure that I can then analyze. And again, this is where fsurb is super useful. So here I'm saying let input equals 42, and then doing some calculation. And when you parse it into a tree structure, you'll end up with something like plus is a node in the tree where the left argument is input, the right argument is function foo applied to input. So you build this tree from your code, and it gets even fancier, because one of the things I want to do later, and I'll show you in a little bit, is to be able to evaluate this sort of lazily on the fly. So as you're editing the code, I want to be able to see what's changed in your code and evaluate only the bits that I need to re-evaluate because this has changed. And again, I'm doing this with my Olympic Games visualization and with a project to sort of make data more transparent, because that's something I care about. But the same pattern you'll see in any financial system, which keeps a track of some pricing models, and whenever a bit of your data change, you re-evaluate some of it. So this is really something that many people are doing in slightly different contexts. And so the next fancy bit you can do is that you can look at the tree and build sort of a dependency graph where the white arrows represent what depends on what. So in my tree, the green circles are both depending on input, which is initialized to 42. And if I change 42 to 43, then the input changes, and therefore I have to reevaluate these bits of the tree. So the interesting bit here, and let me show some code again. Oh no, I changed my keyboard. So while this is starting, the entire project that I'm talking about is all on GitHub, so you can go and have a look at it and fiddle with it. But what I wanted to show you is just this bit. And again, you'll see the same thing I was showing before. Just a discriminated union at the core of some really important part, where the program is actually a list of commands, and the command is either let something equal something, so it's let name equals expression, or it's an expression where we just say like chart.line foo. And an expression can be a bunch of things. It can be a variable. It can be access property of a thing, or call method on a thing. It can be a string, number, Boolean. You can even write functions. It can be a binary operation that takes one expression, an operator, and another expression, or it can be a create list of these things. And again, like this is something that links a lot of different parts of the project together. So you give me text, I'll turn the text into this, and then once I have this, I can write I can write the resharper stuff just by sort of walking over this and figuring out what is where and changing it. And so the bit I wanted to show is testing. I do have tests. I'm one of those people. It's all written in F#, and I still have tests. So what's the interesting thing that I'm testing here is how the parser works. So here's a string, the green stuff, which says Olympics.groupData by team, sum the number of gold medals, and get the data. And I want to make sure that when I turn it into one of these nice trees, then in the tree, there is somewhere a property called SumGold, and somewhere else there's a property getData. Currently, I haven't implemented that yet, but the bit I implemented is this assert sub expression function at the top, where there's a little bit more stuff here, but it basically goes over all the commands and checks if they're, So what it does is that it goes over all the lines of the program and checks if there is some line in the program such that it has this sub-expression. And then in the sub-expression, I just have a look at the sub-expression. If f of e is checking if this sub-expression is the one I'm looking for. If it is, then this is true. Otherwise, I have to look at this expression and see if there's some more nesting. If there is some more nesting, I look at all the sort of sub-nodes in the tree. And if it's not the one I was looking for and there's no more I can go, then it's just false. But then the nice bit is, here if I want to check whether the expression is a property, then I can really just say match E with one of these things in my definition. So if this is property, this is taking the instance name. So instance I can ignore. And then name, there is actually some more information attached to the name, like where is it in the source code. But I think node.name will actually give me the string, and then I'll just return if the name matches the one I'm looking for. Otherwise, it's not a property. Then when checking for call, I'll see for call, and this again, I need to check the name. But then call also has arguments, and for the arguments, I have some other argument that will check whether the arguments are correct. So this is only, there is a name if the thing I'm calling has the right name and it has the right arguments. And finally, to test if an expression is a value, I'll have to say, is it, now which one is this? It doesn't like me. I'll use copy and paste. That's better. I'll have to see if the expression is actually the one of the expressions that represents number, and then I only have to check if it's the right number. So the idea here is, once you have the right representation, it's really easy to write all these different helpers to do things with the representation. And if I parse this code sample and say, is there some gold, it will work. If I say, is there get the data, it will work. But if I say, is there FFF, then it fails because this is not in the sample code. So I could say FFF, and now this will hold as well. And the same thing for the second example. So here I'm checking, this is actually a more fancy test. Here I'm checking that there is a sub-expression somewhere in this code that calls a method called take with an argument 10. And if I run this, this should hold. If I looked for another argument, then it would fail. So the key message here is, again, once you have the nice representation of what is it that you're actually doing, you can do a lot of stuff with it. And here I was showing how you can write some test functions to make the testing easier. But this is the same thing that's happening when I was modifying the visualization to change some of the attributes, because it's really just looking at this tree structure and doing some operations over it. And the last bit is related to the user interfaces. One thing that I was actually sort of thinking about quite a bit when working on this is that we programmers are really used to working with code, and we are sort of quite happy with that. But there's a really nice talk by Feline Hermans who does some research on how people program in Excel. And when you think about how people program in Excel, they can do crazy things. Like, be careful. But don't give your mom Excel, because she'll destroy your IoT and hack your fridge. But the really nice thing in Excel is that when you're doing some work in Excel, you actually always see all the values. Like, you can write some programs, but you never have to deal with abstract things. You're always working with concrete numbers. And that sort of made me wonder, is there something like that we could do for the data visualization? And this is the last bit I want to show you. So this is on the project homepage. There's actually a demo right there. And this works a bit differently. Or it works a bit differently. It has more stuff in it. And what it does is that as I'm typing the code, it will actually give me live previews. So let's have a look at only the Rio Olympic Games. And now I've got just the part of the data set of all the Olympic medals for Rio. And what I can do next is I can group it. And let's group it by country to figure out what country got the largest number of medals. As I'm doing this, you can sort of see how it's changing. And I can do sum the number of gold medals and see it here. The other thing that it's doing is that it actually lets you modify the code in the editor. So here I can say, well, I also want to sum the number of silver medals and sum the number of bronze medals. Where's bronze? Where's sum? Somewhere here. And I can add more transformations, like sort this, and let's sort it. So who's the most unlucky country and has only bronze medals? Yeah, US still has the largest number of bronze medals, but Germany has as many bronze medals as the States and 3 times less gold. So just to finish this, let me remove this and sort it by gold. And then I'm going to get the data and create. No, this is not what I want. Let's draw a little chart. So we are going to get a series where the key is the team and the number is the number of gold medals. And then I can store this somewhere. This is data. And do a chart. Well, there's plenty of countries here, isn't it? So let's skip some of them. Top 10. And here's the chart with top 10 countries. Yeah, so the nice thing here is that you can sort of see all your values as you're editing the code, which hopefully should make it much easier to use. And you can even, in the editor, fiddle with things. And this is all doing quite a lot of custom handcrafted JavaScript, which I obviously didn't want to write in JavaScript. And this is where Fable comes in. And this is also where Elm-style architecture comes in. So if you're staying in this room for the next talk, you'll hear a lot more about Elm. But Elm, at the core, is doing this really nice and simple thing, which is that you write your programs just by writing 2 functions. So you define some state, which is basically what you can see on the screen, and you define some event, which is an action that the user does. And then you write 2 functions, one function that takes the current state, what happened, and what is the new state, and the other function which will take the current state and produce an HTML. And I twisted this a bit, so the render function also gets another function to trigger events. But the key thing is, it's really simple model. You have your state, something happens, you get new state, and then you render it based on the new state. And the only tricky thing is, this wouldn't really work if you were replacing the entire page every time the user moves a mouse. And Elm solves this by having, there's a library called Virtual DOM, which will take this HTML that you produced, compare it with what's on the page, and only apply small changes. So this is really nice trick. And if you wanted to implement something like a to-do list, well, your model, this is your state, is just a list of items, and the current text in the text box. And then you have a couple of events. The user can create a new item. They can remove a specific item by clicking on X, or they can change the text in the input. And all you have to write is a function that will render the current model and a function that will calculate new model when an update happens. And let me show this here. So I need two things. I need my editor, and I'll need to run it. And the Elm model is sort of, it's been really popular in Elm, but it's actually something that you can quite easily get to work in Fable. And so what I'm going to do here is I'll run Node. Sorry, Brian, you're not going to be very happy about this, but my talk includes Node. And all I'm going to do is to say run Fable in this directory and watch for changes. And whenever I edit my F# code, Fable will produce a new version of the JavaScript. And this is all going to be running in the background. And then the other bit I need is to find my folder and open index.html. So here's my to-do list. At the moment, it doesn't do anything. And if I go in here and open my to-do FSX, then you can see here's my definition of an update event and a model. And here's my render function, which currently produces first fake work item and second fake work item. Those are the two here. And then I have some initial state, and I'll start the app. And the first thing I'll need to do to make this work is that I'll need to change the rendering so that it works with the real data. So if I go over all the ID and work items in state dot, what is this, items, and for every single one, I'll generate an li element where the text is going to be the work. And when the user clicks, we'll trigger an event. So trigger is a function that takes an event, and I want to trigger remove event with this ID. And I save it. Now Fable, somewhere here in the background, recompiles my JavaScript, and I refresh it, and now I don't have fake items, but I have the ones that I actually entered at the end of the script. Now it's still not handling any of the events, so I'll need to go here and change this. And this is actually quite easy. So when the action is input, that means the user changed the string in the text box. Then my new state will have input set to this new value. When the action is create, then what I'm going to do is that I'll create a new state with items set to the original items. So we are not removing what was already there. And I'll append a new item, which will have new ID together with the current input. And I can save it. Fable will recompile it. And let's see if I can add hello. Hey, there it is. This is not really a work item, and there it is. And the last bit that I need to do is to say, if I want to remove ID, then state is going to be a new state with items that are filtered. So we're going to do filter, and we have the item, which has item ID and a name, and we are going to keep it if the item ID is not ID. Now, I could make this a bit nicer by adding at least one new line somewhere, but come on. So now I can also remove items. And I think this is really amazing because it all sort of follows from the nice programming model that you have behind this, and it also really beautifully links to this idea that what you need to think about is really this model, is this domain, where once I figure out what are my different events and what is it that I need to render the right state, then the rest of the code is just, you still have to think about it, but it's sort of driven by this key capture, the key bit that captures your understanding about what you're doing. And I'm not really going to show you the whole code for doing this interactive editor, but if you look at it, then you sort of figure out what's the key bits of the domain and what's the key actions. Like the 2+ operations on the right-hand side are sort of buttons that display the menu, and then in the menu you have some items which are the individual actions. You also have, as part of the state, what's the current program and which of the tabs is currently selected. If you look at the full code for this, so this will be somewhere in here. If you look at the full code for it, it's definitely going to be a bit longer, but not that much. This is the full state and the actions of the editor that I was showing before. So I have some menus, and the current state has some code, the body of the code, where it starts, what's the current thing in the preview, what are the sections of the editor, which is the selected entity in the editor, what menu is displayed, and I think the last bit I should have deleted a long time ago. And then you have all sorts of different actions, what can happen. User can ask you to remove some element, select a bit of code, and really from this, you can figure out the rest of the program. So this was the third case where the domain really helps you to understand what is it that you're doing, and you can use it as a sort of glue that combines together all sorts of different parts of the program. And I think this is all I wanted to say. So in summary, I think the first important message is that we should be working on making facts great again. I think one way to do that is to sort of encourage people to actually play with data or understand data. And if we can make understanding data as much fun as arguing about random stuff on Facebook, then maybe people will care. So this is the one message of the talk. There's the technical message, which is, I think, thinking about the domain and what's the core sort of representation of what you're doing. That really helps you build the applications in a sort of nice and easy to understand way where you can separate different aspects. And you can go to the Gamma website and use it if you have some interesting data. You can use FSharp, which has really nice language features for focusing on the domain. And if you're into web, use Fable and make JavaScript fun. And that's it. Thanks.